You are in orbit around the moon, in the last dark minutes before sunrise. Below you, the surface is black. Ahead of you, the horizon should be a hard edge. No air, no haze, rock, and then nothing. Except there is something there, a band of light lying along the edge of the world. And above it, pale streamers rising into the dark, brightening and fading and changing shape while you watch them. You reach for the camera. The camera cannot see it. So you reach for a pencil. That sketch still exists. It is still the most detailed record anyone has of what was seen that morning. 3 robotic landers had already photographed something similar from the ground. And a second astronaut, sitting a few feet away, drew the same thing at the same moment, without conferring. Every instrument sent since to find the cause has come back with almost nothing. So, what did they see? And why can nobody find it again? The moon has no atmosphere worth the name. That is the first thing anyone learns about it, and it is essentially true, which is why the lunar horizon is supposed to be absolute. Sunlight either reaches you or it does not. But before anyone had ever set foot there, 3 robotic landers sat on the surface through local sunset and photographed a line of light hanging along the western horizon after the sun had gone. It lasted less than 3 hours. Then it faded. The explanation the field settled on was dust. The moon is covered in regolith, a layer of crushed and shattered rock built up by billions of years of impacts. The finest of it is powder. And the lunar surface is electrically active in a way the surface of Earth is not, because there is no air to soften what reaches it. Sunlight striking bare ground knocks electrons out of it. Those escaping electrons are called photoelectrons, and losing them leaves the sunlit ground carrying a positive charge. The night side does the opposite. It sits in a steady stream of charged particles flowing outward from the sun, collects electrons from that stream, and goes negative. Between the 2 runs the terminator, the moving line that separates lunar day from lunar night. Along that line, positively charged ground sits directly against negatively charged ground. The electric field there is strong. Estimates put it above 500 volts across a single centimeter. So the picture was clean. Charged dust, lifted off the ground by that field, hanging just above the surface, catching sunlight and scattering it forward toward the camera. A glow with no air required. There was one problem: getting the dust off the ground in the first place. Lunar grains are not smooth spheres. They are jagged, splintered, interlocked, and they cling to one another with a force that has nothing to do with electricity. Christine Hartzell, Xu Wang, Daniel Shiras, and Mihaly Horanyi measured that clinging force directly in the laboratory. For grains of the size in question, it dominates. The electric field pulling upward is not strong enough to break it. Then the numbers arrived. To produce what the astronauts described from orbit, the space above the surface would need to hold something like 10,000 grains in every cubic meter. A survey using a spacecraft star tracker, and later an ultraviolet instrument in lunar orbit, pushed that ceiling down to roughly 1 grain per cubic meter. A dust detector flown specifically to settle the question set its own limit near 100 and found no trace of the population it was built to find. 10,000 required. At most, 1 confirmed. That is not a disagreement at the edges of a measurement. The 2 figures differ by a factor of 10,000. And these are not sloppy instruments. They were built by people who knew precisely what they were hunting for and how faint it would be. The measurements are not ambiguous. The dust is not there. But the people who reported this were not reading a screen. They were looking out of a window. And to understand what that is worth, you have to go back to the man with the pencil. His name was Eugene Cernan. he commanded the last crewed landing on the moon. And by the time he made this observation, he had spent enough time in space to know what he was supposed to be seeing. Before orbital sunrise, he expected two things, and he got both. The solar corona, the outer atmosphere of the sun, visible whenever the sun itself is blocked from view, and a faint wash of light from sunlight scattering off dust that orbits the sun in the plane of the planets. Both are familiar. Both can be seen from Earth on a dark enough night. What he could not account for was the third thing, a glow clinging to the lunar horizon, and above it, streamers of light that brightened and faded and reformed over seconds and minutes. The cameras on board could not resolve any of it, so he drew what he saw by hand, in orbit, in real time. He was not alone. Ronald Evans, flying the command module, made his own drawing of the same phenomenon at the same recorded mission time, independently. Harrison Schmitt drew his version later after they came home, and remembered paying more attention to the streamers than to the glow beneath them. 3 men. 3 records. One of them produced twice at the same instant by 2 people who had not compared notes. James McCoy and David Criswell went through those sketches afterward. Their reading was that the streamers were sunlight scattered by dust well above the surface, blocked in places by terrain along the edge of the disk. Later analysis of the same material implied that whatever was scattering that light reached altitudes above 100 kilometers. None of this was filed away as an anecdote. It became a stated science objective, and decades later a spacecraft was built and flown to lunar orbit in part to settle it. The field was also honest about the weak points. A surface instrument left behind by the same mission appeared to register dust arriving at the terminator, and one researcher later argued that the signal was electronic noise rather than dust at all. Schmitt himself has suggested that transient gas, rather than levitated powder, might be responsible for the glow at sunrise and sunset. So the observations are real, the observers were careful, and the mechanism cannot deliver what it promised. That is where the question sat for a long time. Then the laboratory work found the flaw, not in the observations, in the assumption about where the charging happens. Start with the spacecraft. It spent roughly 6 months circling the moon, dipping between about 20 and 100 kilometers above the surface, carrying a detector built to register individual grains striking it. It found something, just not the thing it went looking for. There is a permanent cloud of dust around the moon. It is real. It has been measured, and its source is not electricity. Roughly 5 tons of interplanetary dust strike the lunar surface every day, and every impact throws material upward on ballistic arcs before it falls back down. The detector registered, on average, 1 grain about 1/3 of a micron across every minute. That work, led by Mihaly Horanyi at the University of Colorado, established a genuine feature of the lunar environment that nobody had confirmed before. But on the question it was sent to answer, Horanyi has been direct. There was little or no evidence of the lofting process at the altitudes the spacecraft could reach. He has also been careful to add that there is room for something to be happening very close to the surface, below the level where the instrument could measure. That turned out to matter, because in a vacuum chamber in Colorado, Xu Wang and Horanyi and their colleagues were coming at the problem from the other end. Instead of asking whether dust could be lifted, they asked how it could possibly become charged enough to lift itself. The classical model assumed the charge collects on the open, exposed top of the surface. It does, just not in the amounts required. The important charging happens underneath, between the grains. A powder is not a flat sheet. It is a heap of irregular particles resting against one another, and between them are cavities, hollow gaps, some of them only a few thousandths of a millimeter across. Sunlight and charged particles filter down through the openings between grains, strike the particles below, and knock electrons loose in there. Those electrons do not escape. They are trapped inside the cavity and reabsorbed on its walls. Here is why that changes everything. The strength of an electric field depends on how far apart the charges sit. Put even a modest voltage difference across a gap that small, and the field inside it becomes enormous. The grains lining that cavity build up large charges of the same sign. Like, charges push each other away. And when that push finally exceeds the force holding the grains together, the grain leaves the surface. The model has been tested repeatedly. Grains do come off. The speeds have been measured around 0.7 of a meter per second for particles roughly 15 microns in radius, and the smaller the grain, the faster it goes. So the mechanism exists. It works. It was simply operating in a place nobody had thought to look. That leaves 3 serious readings of what Cernan saw, and they are not all mutually exclusive. The first is that this lofting process is real and routine, and the glow is what it looks like from 100 kilometers up. The second is Schmidt's, that the light came from gas escaping the lunar interior, briefly scattering sunlight, and dust was never involved at all. The third is the least satisfying and the hardest to rule out, that a single large impact somewhere beyond the horizon threw an unusual quantity of material into the sky that morning, and 3 men happened to be passing overhead. Nothing about that is far-fetched. The moon is struck constantly, and a big enough strike would loft far more material than any electric field could. But an explanation that relies on coincidence is an explanation you cannot test, and it would mean the sharpest observation of the phenomenon ever made was also a one-time event that will never be repeated. The stakes reach further than one sighting. If dust moves this way, then no airless surface in the solar system is truly still. Material migrates. Low ground fills in. Sharp features soften across long spans of time. On the smallest bodies, the smallest grains can be launched fast enough to exceed escape velocity and leave for good, which would mean some asteroids are quietly shedding their own surfaces. And there is a nearer stake. The crews who worked on the lunar surface came home with the same complaint. The dust was abrasive. It clung to everything. It worked its way into seals and fabric and joints, and would not come out. A process that lifts that material off the ground, with nobody touching it, is not a curiosity for the next people who go. It is a design constraint. So where does that leave the contradiction we started with? Here. The instruments were right. The eyewitnesses were right. They were measuring different things. What the orbiters ruled out was a permanent suspended layer of dust, standing above the surface at all times, waiting to be found. That layer does not exist. Those measurements are solid. What they could not rule out is an event, and the laboratory work describes a process that runs in bursts rather than continuously. Harani has suggested exactly that the lofting may only happen occasionally, and that the astronauts may simply have been in the right place at the right time, which produces a strange result. The largest version of this phenomenon ever recorded exists as a pencil drawing. Every camera and spectrometer and dust detector sent since has arrived to find the surface behaving itself, and the open part is still open. Nobody knows what sets off a burst. Nobody knows how high one reaches, or how much material it lifts, or how often the conditions line up. The mechanism has been demonstrated at the scale of a vacuum chamber. The observation was made at the scale of 100 kilometers. Nothing yet connects the two. There is one more thing worth adding. A commercially built lander recently sat on the lunar surface through sunset and returned high-definition images of the horizon as the sun went down. There is a glow above the surface in those pictures. The team responsible has been careful about it, and right to be. They have said plainly that the images require detailed analysis before anyone can determine whether levitating dust produced that light or whether it is sunlight reflecting off distant terrain and off the lander itself. The question has come back with better equipment. It hasn't come back with an answer. That is worth sitting with, because it is not how science is usually described. A measurement that comes back empty sounds like a failure. It was the opposite. Ruling out the permanent layer is exactly what made the episodic answer visible. The empty result did the work. And the oldest document in the entire file is a drawing made by hand, in orbit, by a man who trusted what his own eyes were telling him at a moment when the equipment could not keep up. The next people to stand on that surface at sunset will be the first in more than half a century with the chance to look for themselves.